Statistical tests for categorical data are essential tools in analyzing variables that represent distinct categories rather than numerical values. These tests help determine relationships, associations, or differences between categorical variables. Let's explore some of the most commonly used tests. First, the chi-square test for independence checks if two categorical variables are independent of each other, typically applied to contingency tables. A related test, the chi-square goodness of fit, assesses whether the observed distribution matches a theoretical distribution. When sample sizes are small, the Fisher's exact test is often preferred, especially for 2 by 2 contingency tables. It calculates the exact probability of observing the data distribution under the assumption of independence. For paired nominal data, particularly in pre- and post-treatment studies, McNemar's test is used to detect changes over time. Its extension, Cochrane's Q-test, is applied when there are more than two related groups across multiple conditions. Post-chi-square tests, such as Kramer's V, measure the strength of association between variables, useful for larger contingency tables. If you're working with a binary outcome, logistic regression can model the relationship between the outcome and predictor variables. For categorical outcomes with more than two categories, multinomial logistic regression is used. In cases where chi-square's assumptions aren't fully met, the likelihood ratio test, or G-test, offers a reliable alternative, especially with small samples. When you want to control for confounding variables in 2 by 2 tables, the Mantel-Haenszel test is employed. This test helps control for additional variables while assessing associations between the primary variables. Lastly, tests like the Cochrane-Armitage test for trend and Kruskal-Wallis test are used for ordinal data to assess trends and compare group medians across multiple categories. Understanding the assumptions and applicability of each test ensures robust and reliable results when analyzing categorical data. In conclusion, choosing the right statistical test depends on the structure of your data, the number of categories, and whether the samples are independent or paired.